Okay, so the second question that we're doing is this differential equation, the separable differential equation. So dy over dx is equal to y times sine of x. So again, the first thing you want to do is get your y's onto the left side, your x's onto the right side, or just get each of them on just one side. And so we divide y from the right side, and we get 1 over y times dy on the left side. And we multiply dx times the right side, and we get the integral of sine x dx. So we move the dx to the right side, the x's are on the right side, we divide it by y, and now the y is on the left side. And now we take the integral of both of those things. And remember, we get ln y, or natural log of y, because if you were to take the derivative of natural log of y, or absolute value of y, you would get 1 over y. And so the integration on the right side is pretty simple. Sine, the derivative of negative cosine is sine, so the integral of sine is negative cosine. And we add a plus c1 for a constant. So now what we can do is we can turn the right side into a function of e to remove the natural log from the left side, because remember, natural logs are related to the exponential function, right? So to get rid of it, we can apply the exponential function to the right side, and now we get we get absolute value of y is equal to the exponential to the power of negative cosine of x plus c1, and we can divide up the right side into two exponential functions, because when you multiply them together, you would get what's in the equation right above, which is a plus sign, right? So we could divide them up, or so we could separate them, because if you were to multiply, you would get what's above. So we could separate them, and it makes things easier. So you get e to the c1 times e to the negative cosine of x, and you get the absolute value of y is equal to plus minus. So here, there shouldn't be a absolute value here. This is a mistake. This should be removed, and it should be y is equal to plus or minus, because we're removing the absolute value from the left side. So the right side will be equal to plus or minus e to the c1 times e to the negative cosine of x, right? Now what we could do here to simplify this even further is, since this is just going to be a constant, it's a constant. Remember, e is just a constant. That's all e is, right? It's a number. And it has an exponent of a constant here too. So the constant to a constant is just going to be constant, and the plus or negative doesn't really impact anything. So we could take that entire first term, and then we could define it as a constant. So plus or minus e to the c1 is equal to constant c. We could just set it equal to c. And then our final answer would just be y is equal to c, which was plus or minus e to the c1 times e to the negative cosine x. So yeah, it's pretty cool how you can separate the dy over dx, or the Leibniz notation, in order to actually differentiate, in order to take the integral and actually work through the functions. Like if you take the dx to the right side, and it sets it up in exactly integration form, like it's really, really cool. But you could do that here. This is one of those areas where you can actually separate them. So